Hi, algebra students. We're starting a new unit today. We're going to be working with systems of equations, and our first lesson today is on solving systems of equations by graphing. So I'm going to go ahead and share my screen so you can see the presentation. We're going to start out here with some vocabulary, so make sure you have your student journal handy. We're going to go to the next slide. So our vocabulary is on page 134 in your journal, so be sure to copy these down. And then after you've copied down the two definitions, system of linear equations and solution to a system, make sure you read how to solve a system of linear equations by graphing, also found on page 134. So pause the video, write down the definitions, and please read that section. All right, welcome back. We're going to talk about some different things about systems of equations. So systems of equations by graphing just include graphs of more than one line. If I see two parallel lines, that system of equations has no solution because the lines do not intersect. Anywhere two lines intersect, that point of intersection is a solution. So this has no solution. It could be when you graph your lines that the lines coincide where they're on top of each other. And in that case, those two equations have infinitely many solutions. So two lines that intersect have one solution, namely the point of intersection. So here I've graphed y equals 3x minus 5. I've graphed y equals negative x minus 1. They intersect here at this point 1, negative 2. So the point 1, negative 2 looks like the solution to this system. It's where these two lines cross. To check whether or not a point is a solution to a system of equations, you plug the ordered pair back into each equation. You got to make sure it works in both. So I'm going to plug 1 in for x everywhere and negative 2 in for y, and I want to see if that's true. So my check here we have is negative 2 equal to 3 times 1 minus 5. Well, let's see, 3 times 1 is 3. 3 minus 5 is negative 2, so it works in the first equation. If I plug in negative 2 for y and positive 1 for x in the second equation, I get a negative 1 minus 1, which is negative 2, so it works in both. So the ordered pair makes both equations true, which means it's a solution to the system of equations. So we're going to move to extra practice on page 135. It says, tell whether the ordered pair is a solution to the system. So we're not graphing in this case. We're just taking this x value and this y value, putting it into each of these equations, and we're going to see whether or not that's true. So I'm going to grab my pen, and we're going to try it. And so our first one, I'm going to replace x and y with 3 and 1. So the first equation I'm checking is 3 plus 1 equal to 4. That's my question. That's what I want to check. And if I look, that's true. 4 equals 4. So it works in the first equation. Let's try the second one. Is 2 times 3 minus 1 equal to 3. So that's what we're checking now is the second. 2 times 3 is 6. 6 minus 1 is not equal to 3. This was my question here. 6 minus 1 is 5. 5 is not equal to 3. And so tell whether or not this is a solution. The 0.31 is not a solution. It worked in the first equation, but it did not work in the second. And in order to be a solution, it has to work in every equation in the system. All right, let's look at number 6 here. On the first equation, I'm replacing x with 4 and y with negative 3. So 2 times 4 plus 2 times negative 3. And I want to know, does that equal 2? That's my question. So 2 times 4 is 8 plus 2 times negative 3 is negative 6. And the question is 8 plus negative 6 equal to 2. Oop, that should be a 2. I was just making a question mark. And I do 8 plus -6 and I get 2. 2 is equal to 2, so it works in the first one. So again, we have to try this ordered pair, 4 and -3, in the second equation as well. So I try 3 times 4 minus 3 times -3. And I want to know if that's equal to 21. If it is, it's a solution. So 3 times 4 is 12. -3 times -3 is a positive 9. Is that equal to 21? Yes, 12 plus 9 is 21. 21 is equal to 21. And so since the ordered pair 4, -3 worked in both of these equations, it is a solution. All right, let's look at our next slide. This time we have a graph. They've graphed two equations. We're looking at the point of intersection, and we want to know whether or not that point is a solution. So if I look at number 7, let me grab my pen here. I'm going to switch color. This looks like these two lines are intersecting right here at this point, which looks like the point 2, -2. So it's kind of like we were just doing in that last problem. To me, it looks like my solution is 2, -2. In order to verify that, I need to plug those numbers in for x and y and see if it's true. So the first equation, I have 3 times 2 minus 2 times -2. And I want to know if that's equal to 10 in this case. That's what I'm checking. So we have 6. -2 times -2 is a positive 4. And 6 plus 4 is equal to 10. So it works in the first one. Let's try the second one. We're replacing x with 2 and y with -2. And I can write that right here. Is 2 plus -2, is that equal to 0? Yes, 2 plus -2 is equal to 0. So use the graph to solve the system, check your solution. Our solution is, and we always write our solutions as an ordered pair. So the solution to this system of equations is in fact the point 2, -2. That's our solution. All right, let's look at the second one. This time it looks like these two lines here are intersecting at the point -1, -3. So that's what I want to check. I want to know if that's a solution, -1, -3, and that's a 1. It's kind of hard to tell. All right, so let's try it. Is -1 minus 2 times -3, is that equal to a positive 5? So far what I'm doing is I'm replacing the x and y in this equation with -1 and -1 and -3, because that's this point. So -1, a -2 times a -3 is a positive 6. And -1 plus 6 is in fact equal to 5. So that works in that one. Let's try our second equation. So this time replace the x with -1 again. So is 2 times -1 plus a -3, is that equal to -5? All right, I replaced this second equation now. This is what I'm working with. So 2 times -1 plus -3. Well, 2 times -1 is -2. -2 plus a -3 is in fact a -5. So this point works in both equations. And so that's my solution. My solution is the point -1, -3. All right, let's look at number 9. This time it looks like these two lines cross at, let's see, we're going 4 to the right and 2 up. So the point of intersection I want to check this time is the point 4, 2. So I'm going to put 4 in here and 2 in here and see if it's equal to 8. So is 4 plus 2 times 2, is that equal to 8? Well, let's see. 2 times 2 is 4. 4 plus 4 is certainly 8. So it works in the first equation. Again, you have to put it into the second equation to verify. So is 3 times 4 minus 2 times 2, is that equal to 8? So let's see, 3 times 4 is 12. Negative 2 times 2, would they be minus 4? 12 minus 4 is in fact 8. All right, so our solution to this system of equations is the point 4, 2. All right, let's check the next slide. All right, this time we are solving by graphing. We need to check our solution. So I'm going to graph each one of these lines. So this first one, I have y equals 1/2 x plus 2. So my y-intercept is 2. And my slope is up 1 over 2. And I'm going to do a few points here, try to be accurate. Draw my line as best I can on here. Okay. My second line is y equals negative 1/2 x plus 4. So I go up to 4. I'm going to switch colors here for a second so you can distinguish between the two lines. Okay, negative 1/2 x plus 4. I go 1, 2, 3, 4. My slope this time is down 1 over 2, negative slope. All right, I'm going to do a few more points here. All right, connect those dots with a straight line. All right. And it looks like these two lines, I'm going to grab a different color again. Looks like these two lines are intersecting right here at the point 2, 3. All right, so that looks like my solution, but I need to verify it by plugging those 2 points into each of these equations and see if it's true. So I'm going to try the first one. Remember, my x is 2 and my y is 3. And that green is really hard to read, so I'm going to switch colors again here. Let's go with black, I think. All right, so first equation is 3 equal to 1/2 times 2 plus 2. That's my question. So let's see, is 3 equal to half of 2, which is 1, plus 2? Is 3 equal to 1 plus 2? Yes. All right, let's try the second equation. This time I'm replacing y with 3. And again, we're replacing x with positive 2. But this time, remember, the slope in the second equation was negative 1/2. All right, so is 3 equal to, let's see, half of 2 is 1. This is going to make it negative 1. Is 3 equal to negative 1 plus 4? That's what we were checking. And the answer is yes. So this point 2, 3 here, I'm going to darken it so you can see it a little better. The point 2, 3 is the solution. So we found our point of intersection where the two lines crossed, and we plugged the ordered pair 2, 3 for x and y into each equation and verified that our solution was correct. All right, let's try another one. This time it says solve by graphing, check your solution. Now, a couple different ways I can approach this first equation. The second one, I'll actually start there. I'm going to get a different color here. I'm going to go red for this one. So this y equals negative 3. This is a horizontal line. All right, so I start at negative 3. I'm going to do my best to draw a nice horizontal line. All right, for the second line, or the first line that's listed there, it's written in standard form. So remember, when it's in standard form, one of the ways that you can find some coordinates on this graph are to find your x and y intercepts. All right, that's one way to do it. The other way I could do this is to rewrite this equation in slope-intercept form. Either way will work. It's just a matter of personal preference. You guys probably need the practice. and rewriting. So if I'm going to rewrite this, the first thing I would need to do is move the 3x to the other side. So that would leave me with negative 2y on the left equals, and I'm going to put my x term first because I want it to be written in the form y equals mx plus b. So I'm rewriting, getting y by itself. I need to divide everything by negative 2. So this first equation becomes y equals a negative divided by negative is a positive, and 6 divided by negative 2 is negative 3. All right, so I'm going to graph that second line. My y-intercept is negative 3. It looks like I can find my point of intersection already. My slope is up 3 over 2. I can do a few more points on the graph just to get a nice line. But I can already see where it looks like these two lines are crossing. So it looks like, let's switch colors here again. Looks like our point of intersection is right here at the point 0, negative 3. All right, again, remember, you have to take this ordered pair. That's what I think my solution is. I'm going to plug it back in. So let's see the second equation. I'm just checking, is negative 3 equal to negative 3, right? I only have one y value. It certainly works in the second equation. And now let's take this ordered pair and plug it into this one and see if it works. So is negative 3 equal to 3/2 times 0 minus 3? Well, 3/2 times 0 is just 0. Negative 3 is equal to negative 3, so it works in that one. Also note that I wrote it into the rewritten form, but I could have also taken the 0 and 3 and plugged it into the original to check. I could have done 3 times 0 is 0. Negative 2 times negative 3 is a positive 6, which is equal to positive 6. So I could have plugged it into either the original or the rewritten form to check my point. But 0, negative 3 is the solution. It works in both. So make sure when you're writing your solutions, you are writing them as ordered pairs. All right, let's look at our next one. This is extra practice number 14. Solve by graphing, check your solution. All right, so I'm going to grab a couple different pen colors here. So first I'll start with red for this first one. My y-intercept is a positive 3. My slope is up 1 and over 4. And again, I'm going to do another point just so I can be more accurate here. Try to go through that line. That one's kind of curvy. All right, our second line, grab blue this time, is 3/4 x plus 5. So 1, 2, 3, 4, 5. Our slope, we're trying to go up 3 and over 4, which is kind of going off the charts here. Okay, so if I can't really go up 3 and over 4, I can go down 3 from here and 4 to the left. All right, looks like my point of intersection is going to be right there where those two lines are crossing. Let's see how accurately I can draw here. All right, so there's my two lines. Oops, I missed this guy pretty much. But it looks like this right here is my point of intersection. That kind of messy, sorry. Let's grab the different color. So I think my point of intersection here is the point negative 4, 2. That's where they were crossing if I'd done a better job at graphing the second blue line here. All right, so let's see, negative 4, 2. I'm going to plug those into my equations and see if it's true. So my first one is 2 equal to 1/4 times negative 4 plus 3. That's what I want to know. That's my check. Let's see, 1/4 times negative 4. 1/4 of 4 is 1. This makes it negative 1. Negative 1 plus 3 is in fact 2, so it works in the first one. Let's try the second one. Is 2 equal to, oh, there should be a question mark, by the way, not a check. I was checking that. All right, is 2 equal to 3/4 times negative 4 plus 5. All right, let's check that one. All right, so 3/4 times -4. 3/4 of 4 is 3. This is going to make it a -3. And remember, if you can't do those fractions in your head, you're welcome to use a calculator. All right, so is 2 equal to -3 plus 5? Yes, -3 plus 5 is a +2. So our solution is in fact the point -4, 2. Again, be sure to write your answer as an ordered pair. All right, let's look at the next slide. Your assignment is your next slide. You have a worksheet. If you're working from home, be sure to print the worksheet or copy the problems onto paper. If you're in class, you will get a hard copy of it. So good luck and email me if you have any questions.